Welcome to today's lesson on solving integrals using partial fraction decomposition. In this video, we'll explore how to solve the integral of x plus 3 all over x squared minus 4x plus 3 with respect to x. Let's start by writing down the integral. First, we need to factor the quadratic expression in the denominator, x squared minus 4x plus 3. This factors into x minus 3 times x minus 1. Great, now that we have factored the denominator, we can set up our partial fraction decomposition. We'll express the original expression as the sum of two separate fractions by writing it as a over x minus 3 plus b over x minus 1. We now need to solve for the constants a and b in the partial fractions decomposition. Let's multiply through by the common denominator, giving us x plus 3 equal a times x minus 1 plus b times x minus 3. We'll expand the equation, grouping terms with x and constant terms, to yield a plus b times x minus a minus 3b equals x plus 3. Such comparison forms the basis to solve for a and b. We'll solve dash 3b, a equals 3, and a plus b equals 1, which helps us find a equals 2 and b equals minus 1. Plugging the values for a and b back into our expression, we get the partial fraction decomposition. So, the integral becomes the integral of 2 over x minus 3 minus 1 over x minus 1 with respect to x. Now we can integrate each term separately. The integral of 2 over x minus 3 is 2 times the natural log of the absolute value of x minus 3, and the integral of negative 1 over x minus 1 is negative the natural log of the absolute value of x minus 1. So the integral of the expression becomes 2 times the natural log of the absolute value of x minus 3 minus the natural log of the absolute value of x minus 1 plus the constant of integration. In summary, we successfully solved for the integral of x plus 3 over x squared minus 4x plus 3 using partial fraction decomposition. We factored the denominator, set up partial fractions, solved for constants, and integrated each term step by step. With practice, mastering this technique will make solving complex integrals much easier.